Hello everyone, this is Planey McPlaneface, and Planey is one of the newer RC planes that have joined my 3D printed fleet. This one wasn't designed by myself, I found the plans online and they are available for free, so if you want to build your own, you have to pay for just the filament and the electronics, which is arguably pretty cheap for what you get. So in this video I want to go a bit over how I built mine, because I built it in a bit of a special way, not really how it's intended to be built, and I want to give it a bit of a review, because this is a sort of plane that I wanted in my fleet. This is what I intend to be a sort of trainer, because I want to do with this what I don't quite want to do with my more expensive and complex jets. So let's get right into it. Before we continue, I'd like to thank my sponsor, PCBWay. If you are working on a project of your own that requires parts that would be hard to make yourself, or just generally parts at a much higher quality standard, you can go to PCBWay's website and order anything from PCB prototypes, assemblies, CNC parts, 3D printed parts, as well as stencils or even flexible circuit boards. The ordering process is simple. You just upload your files, tell them some stuff that you need, and you'll quickly receive a quote, which once accepted, will mean that your part can get shipped out within as fast as 24 hours. And if you have any questions or require further help, they even have a live chat service that stands ready for you. So if you need some custom-made project parts, don't delay, go to PCBWay today. This plane is a sort of mixture of T-28 or T-8, your low-wing, propeller-driven trainer aircraft from the Americans, and yeah, that's pretty much what it is. It behaves like them too. Now, these types of planes are a little bit special. They technically count as warbirds because they are military planes. They were trainer planes to train the pilots before they go into the actual military duty planes. And they have some interesting flight characteristics because of that. They are usually more floaty, they're usually a bit more agile, a bit lighter, and that makes them better RC planes in my opinion, because you will be able to do a lot more with these types of planes than with the average like Mustang or Spitfire or P-47, whatever you might have. So when I saw this thing online, that was pretty much exactly what I wanted. It was propeller driven, so I wouldn't have to design around an EDF that pulls a lot of power and quickly sucks the battery dry. It has a rudder, elevator, and ailerons, so it has all types of control surfaces. The only things it doesn't have is flaps, but more on that in a bit. And it even has a landing gear, which is not actually what you get on the T-28, because this is a tailwheel landing gear. It has a little tailwheel at the back, you can see it right there. Because the actual T-28 has a tricycle landing gear where it has one in the front and then the two ones in the front are like further back. Tricycle landing gears are fine for jets, but for propeller planes I really prefer tail wheels just because they're just in my opinion easier to work with. So I like that this change was made to the design. So before I get into any flight characteristics and reviews, I should talk about how I built mine, because the way how you build your model, it can have some pretty severe impacts on how it flies. So I should first make clear how I built mine, and specifically what I did different to what's intended to be done with this model. You see, this model is actually intended to be printed out of PET filament and not lightweight PLA like I've done mine. The person that designed this plane mainly specializes in recycling old plastic bottles into 3D printer filament, which is of course PET, quite similar to the PETG that you can buy on spools. That filament does not have any lightweight active foaming offerings like PLA that I'm aware of, and so it's going to behave pretty much like a non-lightweight PLA plane when you print it out of the intended filament. Now this can work, the plane is going to end up a bit heavier, but the plane has some specific designs to make this work. Specifically, it has been designed around being printed in vase mode. Now in vase mode, you don't print layer after layer, you actually print a continuous spiral from the bottom to the top. This is mainly done to have better extrusion quality because you don't need to retract or travel, but it can also be done to print some pretty lightweight parts. Specifically, the trick that everyone uses, which has been, as far as I'm aware, pioneered by Tom Stanton, is you cut a little slot in the part, and then your slicer will detect that as an outer edge, and it will print that outer edge and that would result in a sort of spar if you put it in the wings, for example. On my model, that is not what I did, because this feature is pretty much something that, as far as I know, only happens in Cura, and Cura is not a slicer that I particularly like. I've tried it many times, but even when I use the exact same settings I use in other slicers with good results, I just get problems. The extrusion quality isn't great, there's always stringing, and I just don't really know. I just can't get Cura to the same quality that I get out of Prusa Slicer. So I use Prusa Slicer pretty much exclusively. And the problem with Prusa Slicer is it has a feature where when it has really, really small details that are technically too small for the printer to print, it just ignores them. And these small slots that you cut in the parts to create the spars are features like that. So Prusa Slicer just ignores them, and it will only give you the outer contour without the internal reinforcements. So, in addition to printing this out of lightweight PLA instead of PET, I was also forced to use the regular layer-by-layer print scheme, meaning this has regular 5% gyroid infill in it and no other internal structures. I can say that for this model, that's fine. The model flew fine. It even went through some rough landings and some partial disintegrations, which we'll get to. And it's fine. Like, if you load the wings up, yeah, they flex up a bit, but they're not gonna break. And that is with no spars in these. Like, you can see it more on the images from the designer of the plane, because the PET filament is slightly see-through. But the only spars in the wings are for attaching the landing gear, and they end right here. Everything else on the wing is just lightweight PLA. There's no reinforcements in there. And that's fine. This plane is very, very low wing loading. It has a lot of lift. It has a very thick aerofoil. Like, it flies just fine. Then when it comes to the electronics, I built this pretty much the same way I built my other prototypes. I went to the used electronics parts bin and picked out whatever fit the model. So, we have 4 9-gram servos. 2 of them are here for the rudder and elevator, and 2 more are below the wings for the ailerons. Then for the ESC, I grabbed this blue one, and that's the only thing I know about it. I have no idea what the spec of this is. I can just say that on a 3S pack it works. From the sizes, probably around 30 amp rated ESC, so 3S is probably the highest voltage you should put through this, because at 4S I'm not too sure it's gonna survive. And same goes for the motor. We did measure the RPM, and it came out to being around 730 to 750 kV, and we put a 9x6 prop on it. We also flew with an 8x5 prop first. That worked. The plane can fly, but it lacks some power. Like, it's not really fun. It feels like it's just lacking a lot of power. So I recommend going with a 9x6, or maybe something even bigger if you perhaps want more power. Then for the receiver, we went with a 6-channel without a gyro, and this flies fine without a gyro. Like, it's very floaty, it will feel the wind, but this is not super unstable like your EDF jets. This is a very docile flying plane, since again this is based off a trainer aircraft, which are usually meant to be kind of docile. You can also see from the wings that they have this mostly square profile. There's a little bit of dihedral in there, there's a little bit of sweep, but not really a lot. So this thing, it stalls like a trainer, which is that once it stalls, it just takes the nose down a bit and it starts gliding. It's not gonna fall from the sky like a rock. And it certainly isn't gonna drop a wing from under you. So then, when it comes to weight, the plane without a battery is pretty much exactly 600 grams. And with the battery, a 3S 2200 that I chose, the weight comes out to around 780 grams. That's heavier than my F111, though admittedly this plane is also quite a bit bigger than my F111. And it's actually quite a lot lighter than my FJ4 Fury, which is more comparable in size to this, because the Fury is around a kilogram, fully loaded with the battery. Though admittedly that also has an EDF and it flies with a 4S 2200. So overall, this plane is kind of comparable to another model that I also have, which is a Multiplex Funman, which is a shrunk down Fun Cup. Also flies on a 3S 2200, has very similar wing size and span, with the difference being that the Funman is a high wing trainer and the motor is a bit less powerful than what we put in here. With the 9x6 prop that we installed so far, there is plenty of power now. It can basically climb with a nose angle of 45 degrees, but it can't quite hover with the current setup. You might need a bit of a larger prop. Maybe you would have to rebuild the entire thing to take 4S packs to get enough power to hover. It currently can't do it, but there's plenty of power to do other things. But here's a point where something a bit special about this plane comes to play. So, when it comes to the elevator and rudder, you have plenty of authority. I didn't even have to expand the rates to 150% to get quite a lot of response from those control surfaces. But the ailerons. The ailerons are special on this one, because you can see they are very close to the fuselage. This is not where ailerons usually are. They are usually outer on the wing tips, but not on this model. I don't really know why that is. The only clue is that in the model files, the ailerons are actually called flaps. So it could be possible that at some point during development of this plane it was intended to have flaps and ailerons, but then for whatever reason the creator decided to not include flaps and just repurpose them as ailerons. This leads to a bit of a problem, because the ailerons on this are not very responsive. Them being so close to the fuselage just makes them less effective, and I had to put them to 150% travel, and it's still noticeably slower in roll than everything else. This is a characteristic that you're gonna have to be careful with on this plane, because you just can't roll it level as quickly as some other planes that you'd be used to, especially in comparison to the responsiveness on the elevator and rudder. Now, me personally, I'm not too annoyed by this, because again, I wanted this as a trainer, and specifically as a trainer for larger models, which by nature roll slower. So this is actually pretty decent at emulating that, but I can see how this is a bit of a problem for people who don't want to use this model for specifically that purpose. Thankfully, because the files are all available for free, you could basically just hop into a CAD software and change the model files to your liking. And I've actually been considering to do that. I've been thinking of carefully cutting the wings where the ailerons end, and then replacing them with longer full span ailerons that go all the way to the end of the wingtips, and then reattaching everything. That way there's gonna be plenty of roll rate, and you may even be able to repurpose them as flaperons, where they're both ailerons and flaps at the same time, because at that point the control surfaces are so massive that you don't need the full rate of travel. Something similar has also happened with the landing gear. Now, if you look at my model, you see that the landing gear is like this, it's bent forward. And this is not how the plans intended it to be, not the original plans at least. The original plans intended the landing gear to stick straight down. The problem is that positioned the front wheels too far back, and that leads to the problem of if you want to take off from grass, the plane is going to do this. And the same thing will also happen on landing, which is obviously not good for the airframe, because over time you'll damage it from flipping it over on landing. And of course you'll also have to throw it for takeoff every time instead of taking off from grass, which is something that I specifically wanted from this model. The short-term fix was to just bend the gear forwards, and now everything works just fine. But I did actually mention this in some feedback to the creator, and they have now updated the files so that if you download the plans now, it will include a bent forward landing gear from the factory, so you don't really need to worry about this. Another caveat is that there's not really a lot of instructions when it comes to this model. I picked the electronics and the spec and the center of gravity basically myself. Specifically with the center of gravity with the 3S2200, we came out to basically here. You see where that strap ends? That is where we put the aft of the battery as well. That looks better. So the battery ends right here, and that is okay for the center of gravity. We also used to fly it with the battery all the way back, touching the servos, but that way it becomes very, very, very finicky. Like, it can fly, but it is so tail heavy that it might be too much for some people. So for a better flight experience, I would recommend to put it like about a centimeter away from the servos if you're flying with a 3S2200, which is around 180 grams in weight. And there's one more thing. So this model has a very nicely designed front air inlet that is going to let plenty of air from the airflow and just from what the propeller pushes into your airframe to cool down your ESC and everything else that might generate some heat inside. The problem is there's no outlet for that air. It doesn't come out anywhere. I resorted to just cutting some holes in the canopy and in the aft of the fuselage, but the plans don't include any air outlets. That's a bit problematic because, again, I don't know what spec the ESC I used is actually, so I'd rather have too much cooling than not enough and have this thing melt down mid-air. And especially if you choose to put a 4S setup in yours, you probably need some cooling. My FJ4 Fury doesn't have a lot of cooling, and it has a 45 amp ESC that does get quite hot after just a 4 or 5 minute flight. And this being a slower propeller driven model means you're going to have a higher flight time. Specifically, with the current setup, it has an 8-minute flight time, and sometimes you even end up with the pack not even fully discharged yet, like it comes in at like 40% charge still. For reference, you want around 30% for storing your pack without it breaking down over time. So when it comes to flying, this model is pretty efficient. At 3S, I can fly it at about half throttle just fine. You just have to be a bit cautious with wind, because if you get a lot of tailwind suddenly, then it's going to start dropping, because that's very close to the sort of minimum speed that it can do. And when it comes to landing this model, it's actually a bit different than what you would expect from a trainer. A lot of trainer aircraft work the way that you do your turn to final and you just cut the throttle, you turn the engine completely off and you just glide in. This doesn't work on this model, because this model, despite being fairly efficient, is not a great glider. It has a very steep descending slope if you turn the engine completely off. It's more a space shuttle than, let's say, a Cessna. So it will come in pretty fast and pretty steep, so you should use some remaining throttle for landing, something around 30 to 40% in my experience. That is also how I ended up with some damage on this model. 2 times now I've not used enough throttle when landing. One time because it was the very first landing and I just didn't know it wasn't a great glider. And the second time when we had a lot of wind, and then just about when it was about to land, the wind turned and suddenly it stalled from 2 meters out in the sky, and there wasn't enough space left to turn the engine back on and get the speed up. The first time not much happened. This little bit of damage is the only thing it took from the first crash, and yeah, that just shows you how robust this airframe is. But the second crash was a bit more severe. The landing gear on the right side pushed through, you can see this hole right here, and this section of the wing broke off completely. It was easy to glue it back together, but yeah, you can break this plane if you do a pretty hard landing. We also at some point ended up snapping one of the elevators. You can see a bit of glue right here, just from throwing something heavy on it without paying attention when we were storing it. So this is not quite able to take as much abuse as your regular foamy. It is pretty sturdy for a 3D printed plane. For example, my Fury, it would have shattered if it went through the same experience as this. But you should still be a bit careful, like handle it like a balsa plane essentially. Just that this one is a lot cheaper and easier to replace if you do break it for some reason. So yeah, all in all, what do I think of Planey McPlaneface? I like it. It's one of my favorite planes to just take off and check how the wind is, how it feels. I will use this primarily to test and learn new maneuvers, because again, this plane is a lot more docile, a lot slower than my other planes, so it's just easier to work with this one and when you try new experimental things. And I think with a couple mods, this could also be a lot better. I've been thinking about this. It really depends on how much time I have, but I was thinking I would take the plans, I would modify the plane so that it has the full span aileron, so that it has some air outlets, and also a better motor mount, because I forgot to mention this. The stock plans don't really include a proper motor mount. And that's mostly because pretty much every RC plane motor has a slightly different mount. So we ended up designing our own mount that went in here. I could maybe include something like that as well, and then repost it as like an add-on to the files of this plane on printables. I can't promise anything, like this is gonna be a backlog project and I have quite a lot of things going on right now. So I don't know if it's gonna happen, when it's gonna happen, but it is something that I was thinking about. And perhaps if one of you watching can do CAD, maybe you can just take that idea and do it yourself. So yeah, at the end, do I recommend that you make a Planey McPlaneface, or whatever you end up calling yours? I do recommend it. It's a pretty nice model. It could use some mods like I just said, but overall it is a pretty nice plane. It is a decent second plane, I would say. This is not something you should like start out completely with. This does require some experience with RC planes, but I think this is a good advanced trainer, so to say. Like first you get an Aero Scout, or what I learned with the Multiplex Funman. Those are easier to fly than this. But then once you feel you're ready to, handle something more advanced, you could make one of these. Because like I said, they do need some throttle when landing, the ailerons are not super responsive, it's a low wing, so it has slightly different characteristics when flying than your high wing trainers. And of course you can mod this thing to fly 4S and have a super aft CG and then like do crazy maneuvers with this if you want to. And as far as cost goes, this is like an amazing deal actually. Since the plans are completely free, available on the internet, you end up paying like 50 to 70 euros only to get the plane, not including your transmitter and receiver, because there's just too much out there to really gauge down a price. It really depends on what you have. But yeah, like if you think about it, the filament, that's like maybe 10 euros worth. You can get a 30 to 40 amp ESC for around 15 euros, that makes 25. Add another 15 for the motor, that makes 40, and then another couple servos, and you're basically at 50. Then some slightly extra things like the metal rods for your wheels, and yeah, you're in that sort of 50 to 70 euro range, because I didn't count things like shipping cost here either. And for that price, this is pretty good. Like for that price, you basically only get toys. And this is a proper RC plane that flies like a proper RC plane. So, Planey McPlaneface, or the PET Recycled Filament RC plane, or whatever the actual plans are called, they get a thumbs up from me. I like this, I'm gonna fly this a lot. This is already kinda the one I fly the most of my 3D printed jets, or planes in general, because my FJ4 Fury, it has a tendency to crash. And my F111, well, that's still in development, and basically none of the prototypes ever get more than like 1 or 2 flights in. Speaking of, SN5 did fly. Not super successfully, but it did fly, and there will be a video about that, so stay tuned. And yeah, with that, I think that's gonna be it for this video. It always feels kind of bad that I can't show you any flight footage, but I don't have any cameras that I can put like on my head to film while I'm flying, and there's not really that many people around that are willing to stand next to me and film my plane for 8 minutes because they want to prep and fly their own planes, if they are there at all. So I'm gonna see if I can like buy a head-mounted camera or something, give you some flight footage in the future, but yeah, for now, just seeing the model, it's gonna have to be enough. Anyway, if you're still here, thank you for watching, and until next time, goodbye.